let's go back to this sinusoid function and maybe say I don't want it to end at 0.6. What if I want it to be 0 after 0.6 seconds? I want my forcing function to be 0. Well, and then I can come back to Python and I can say, well, I actually want to loop over every single time step, and if that time step is less than 0.6, I'm going to return this math function. If not, then I'm going to return 0. So maybe the first thing I need to do is create a time that's longer than the 0.6 seconds I initially proposed. So I'm going to create a new linspace function that starts at 0 and ends at, say, 1 second. And it's going to have number of elements associated with number of steps. And I haven't defined number of steps yet, but maybe I want to end at a final time t, and I'll say that final time is equal to 10, and then I'll say this number of steps is just equal to that time t over some time increment, which I'll call dt, which we'll just specify as 0.1 seconds for right now. And so if I run this, what it does is it comes up with a warning, and it might say, hey, I don't really quite understand what this warning is. And this warning is associated with ns. And so what you see if you print ns, which is just this final time over the time increment, you get something that we're going to term a float. It has a decimal associated with it. Well, if you go to this linspace function and were to Google it, what you'd see it takes initial value, a final value, and then it takes the number of elements. Well, the number of elements that are in this thing is typically always an index. You can't put like 10.5 elements into time. And so what I might want to do instead of a float, I might want to specify that I want this thing to be an integer. And when I print the number of steps again, we now see that that decimal points away and it returns this number of steps as an integer, and the warning also disappears. And if I then print this new time array, what you're seeing is that it's going from 0 to 1, but it's not being incremented by 0.1. And that's because I'm starting at 0, so I have an extra sort of, this time array is starting at 0. So I have one extra element that I need to add to my array, so I actually want it to be of length ns plus 1. And so now you see it starts at 0, ends at 1, and rather than having number of steps of 10, it actually has a length of 11 elements to start at 0 and go to 1. And so what I've done is I've actually overwritten my original time with this new time that starts at 0 and has 11 increments. And in fact, if I were to even go up above and say print time, because I've already run these things, it's still going to read the same time increment that I overwrote it with. So Jupyter Notebook's work is in everything is in order. So everything that you do is already in the system, and if you overwrite it at a later date, that thing is overwritten and the original one disappears. So it's all about like when you run each of these cells, and that's how it understands which variables are overwritten at which times and which variables are initiated before others, and so on and so forth. So it can only read in order of the cells that you run. So I've created a new time variable. So basically what's happened is I've deleted this time variable and I've created something new that goes from 0, is incremented by 0.1, and it goes down to 1 second. And now I have a new indices associated with this, and you'll see that it goes now, my index goes from 0, it ends at 10, and you'll note that there are 11 elements in this index list, and there are 11 elements in this time list. And so now what I might want to do is loop over each one of these time indices, check to see whether it's less than 0.6. If it is, do some math. If not, just return some zeros. And so typically when you want to loop over something, you want to create a for loop. And I like to loop over the indices, so I'm going to say for j in range, and I want to loop for j starting at 0 to j ending at 10. And so I can go from 0 and then to basically the length of time, which is 11. So it's not inclusive, and so this is actually a less than. So it starts at 0 and goes to less than 11, which is 10. It's not a less than or equals, and then a colon. And why don't I just print j? I like to print every line of code I write to see if that's correct. And we see it goes from 0, it ends at 10, and that corresponds to the j's that I'm trying to loop over. I can then say, well, print j, and then also print time. And so let's say I want to grab that time at index j. And let's see what that does. And you see it goes from 0, so j equals 0. It returns time at 0. This for loop increments that j by 1. And so it will return, it then reads t at j equals 1, which equals 0.1. It increments j by another 1, so it reads j equals 2, which corresponds to a time t equals 2. And basically steps through these j's, reads the time increment, increases by 1, steps through the j, reads the time increment, increases by 1, and so on and so forth until j equals 10, at which point it exits the loop because, again, it doesn't reach 11, it's less than 11, non-inclusive. And so I want to create some sort of p from this new time that I have. And so that's 10 times sine of pi times time over 0.6. And we already know this isn't going to run because we've already seen this before, and I'll comment this after right now. That name sine is not defined, and actually we're reading an entire array, and we said we wanted to loop over each time increment in the array. So maybe instead of for doing this math for all time, what I want to do is actually loop over just one instance of time, so 0.0, 0.1, 0.2, 0.3, etc. And because this is now one instance, I can actually get away. I'm not doing math with an entire array, this t at j. Remember when I printed t of j, it was just one number. So for example, if I printed t at j equals at j equals 5, it should return 0.5, which is just one number. It's not the entire array. It's just t at 5, which is just one number. So I can actually use now the math library for the pi and sine functions. Now, I'm not quite sure if this is right yet. So what I might want to do is take the right-hand side of this equation, or actually, let's just run it and see what happens. And it runs, but like I said before, I like to print everything. And we see that what's happening is it's only printing one value of p. So what's going on here? Well, what it's doing is it's creating a p, and then it's going through the loop again. So it starts at j equals 0, and it basically returns this number at j equals 0, and then it calls it this variable p. And then it loops again, now j equals 1, does some math with t at j equals 1, and it returns some number, and it actually overwrites the previous p. And so what you'll see when you look at this is it creates a 0, and then it deletes it, overwrites it with a 5, deletes it, overwrites it with 8.66, deletes it, overwrites it with a 10, and so on and so forth. And it only stores one number until it gets down to the end of the loop, and it returns that p equals negative 8.66, which is, again, only one number. So how do we instead store this in some sort of array, because we want to keep a history of this function p? Well, what I can do is I can create some sort of container that at first is just filled with zeros, but then I can start filling it with these values. And so I can create an np.zeros array, and I can create it to be the same size as my time array by sort of saying this np.size. And I can print p, and you'll see that it's a 0 array, and I can print p again, and nothing happened. Well, why didn't anything happen? Well, it's because I'm taking this entire array p, and I'm saying, well, let's just delete that entire thing and just call it by a single number. So if I want to store this single value into this array of zeros that I created, I really need to say I want to store it at a certain index j, which in this case is p at j. And you'll see when I print p, that returns a vector that is filled. And so what it's doing, what we did was we created a storage place that we knew what the size of it was because we wanted it to be the same size as our time. And then we basically looped over each p and then started filling it with this sine function. It was made up of pi times a single index. I'm not doing all the math at one time. And then we basically said, let's go from j equals 0 to j equals 1 to j equals 2 to j equals 3, all the way up until j equals 10, which is less than 11, and then I will exit my loop. Okay, but this isn't quite doing what we wanted it to do. Remember, in the initial statement, we said we just wanted the sinusoid function for time less than 0.6. And so what I can do is I can modify this slightly. So for example, in Excel, what I might say is if this time increment is less than or equal to 0.6, then I want to return that math. So 10 times sine times pi times t over 0.6. Else, if my time increment is greater than 0.6, then I'm just going to return 0. I've entered too many arguments. How is that possible? 10 times sine. I'm missing a parentheses. Okay. And so now, as soon as time is greater than 0.6, it starts returning 0. So how do I do that in Python? Well, we're going to use something very similar to what we do in Excel, except we're going to use an if statement. So what we're going to say is if that time increment that I'm looking at is less than or equal to 0.6, then I'm going to do this math. And I need a colon there. Colons are very important in doing these sort of if-else statements or for loops or really any sort of loops that look something similar to this. And then if it's greater than 0.6, I've already created a NumPy array of 0, so I'm just not going to do anything. And so now when I print p, it basically starts at 0, j equals 0, and it looks at that time at j equals 0, which is 0, and it's less than 0.6, so it does some math. And then it increments to j equals 1, looks at the time again, and does some math. And it does that and does that and does that until j equals 7, which corresponds to a time of 0.7. 0.7 is greater than 0.6, and it just skips this line altogether. It doesn't even do it. And so it keeps it at 0. Now, if I wanted to reinforce that 0 a little bit more, I might create some sort of else statement, and I might say that p at j equals 0, which basically does the same thing because, again, we created a container at the start that was already made up of zeros.